So let's try out this problem of CUET. This is CUET 2023 problem 26. Strategies. One strategy can be to find the distribution of y. The another strategy can be using something called lotus. Lotus is a very interesting strategy that is mentioned in the Blitzstein book, Introduction to Probability. It says that if, let's say, you know the distribution of x, let's say x follows normal, 0, 1. You want to find expectation of x squared, rather any function of x. So how to find expectation of a random variable y? You find the distribution of y, and then you find its expectation, right? But what is lotus says? So the whole, the expanded form of lotus is the law of the unconscious statistician.
Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of.
So based on this, you can also do it using lotus. Like, instead of just finding, can we just use the similar such things to find it out? The expectation of y and expression of y squared. But what we can do to find it? Let's see. That's the whole part of the problem. Before focusing on the lotus, let's look into this distribution. X choose y is less than equal to x, and 1 by 4 whole to the power x, right? And x is greater than equal to 1. This is the whole problem. This is a PMF. Now you can clearly see something really interesting. And this is where a new problem solving strategy, I really prefer to call it, it's called the projection strategy. So what is a projection strategy? The projection strategy is if you project a certain idea to an old idea and try to connect it. How does this translate in this scenario? Rather, what does it have to do with this scenario? So we can update it as something called probability projection strategy. What does it mean? It means that whenever you see a distribution, you try to connect it to an old distribution or a known distribution. It is what I call PPS, a probability projection strategy. And this is generally true. And that's how our human minds work, right? We always perceive a new event with the perspective of the old events, right? So we are projecting the new event or new experience based on the old events, and we correspondingly judge based on that. But it's useful because that's how our minds work. So what we are going to do now, and we're going to understand, is how is this x choose y 1 by 4 whole to the power x related to other known distributions, rather which distributions are they related to? And you can easily understand that this looks like, so there are two kinds of distribution which really has choose in them. One is binomial and one is negative binomial, and also hypergeometric. They have choose inside them. Now let's try to, so therefore the next part of the discussion will be trying to understand. So I am going into the depth of this problem so that not only just understand the solution of this problem, but you can reproduce the idea to another 1,000 problems. That's how I want to change the focuses on teaching, right? You can reproduce the ideas in the future to many other problems. And that can only happen if you go into the depth of the problem, understanding truly what it is asking and how to attack it, and attacking it and understanding and solving it from multiple dimensions. If you fix kind of x, observe this, and our creative energy will be directed towards understanding this. So if you fix x and if you see the y, let's say you fix x, first experiment, fix x and see the y is between 0. You can see y is greater than equal to 0 and less than equal to x, because that's what is given here. Y is greater than equal to 0 and less than equal to x. If you fix x, then you see that this x choose y looks like that n choose k, where y is the k and x is the n. And then it was p to the power y and 1 minus p whole to the power n minus, or that x minus y. This is how it should look like. Observe that if it is half whole to the power y and 1 by minus p will also be half whole to the power x minus y, then multiplying it, it will become 1 by 2 whole to the power x, right? But here it is 1 by 4 whole to the power x, right? So what if we just focus on just 1 by 2 and keep the rest into 1 by 2 whole to the power x. So you divided it into two halves, 1 by 2 whole to the power x and 1 by 2 whole to the power x. Remember that x was fixed. So we have got a distribution here, binomial distribution, right? If x is fixed, then what is the interpretation of this? A sudden random distribution coming out from a joint distribution. And that is where the relationship between conditional distribution and joint distribution comes up. If you observe, we stated that x is fixed. So this is kind of the distribution of y given x, because x is fixed. And naturally, if this is totally f of x comma y, this should be nothing but this, right? So that's the beauty of it, right? By just looking into this probability projection strategy of finding a distribution, you found out the conditional of y given x. And how do you know that this is x and y? Because it's always unique. You can only do it in one single manner. There is no other way. It's easy to prove that you can do it in only unique manner, right? I mean, there cannot be any other distribution of y given x and x. If you have found out one, this is the one, right? Beautiful, right? So at any point of time, if you like certain idea, please feel free to give some reactions if you really like it. It will help me to understand that you are understanding. So just by this probability projection strategy, you have found out the distribution of y given x and x, right? So what does it turn out? That y given x follows binomial, or rather y given x is equal to x follows binomial x comma half. So this must also be a distribution. And you can see that half to the power x is a distribution of geometric distribution with probability half. Remember, x is greater than or equal to 1. So it is not counting the number of failures, it's counting the number of trials to success. Because counting the number of failures to success will be greater than or equal to 0. Counting the number of trials to success will be greater than or equal to 1. And x is greater than or equal to 1. This is the minute things you should observe, because if you take it to be failure, the expected value of x will be different. Okay, but you have understood it the same. So therefore, this small aspects is very, very important. And it totally makes so much sense, right? It's beautiful, right? Do you like it? Give a reaction. How you can connect, how you can use a strategy to just bifurcate into these two distributions, right? Beautiful enough. But next question is that, will this really help me to find the expected, rather the variance of y? Will this really, really help me? And that's where the next part comes.
To book a trial class for your preparation courses of IITJM MS, ISIM STAT and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.